Producing hydrogen from water involves a process called electrolysis, which requires an electric current to be passed through water to separate hydrogen and oxygen molecules. Here are the basic steps for creating a hydrogen plant from water. Obtain a source of water. The first step is to obtain a source of water that can be used in the electrolysis process. This can be any type of water, but purified or distilled water is typically used to ensure there are no impurities that can interfere with the electrolysis process. Set up an electrolysis cell. An electrolysis cell is a device that allows for the separation of hydrogen and oxygen from water using an electric current. The cell consists of two electrodes, typically made of platinum or another conductive metal, that are placed in the water and connected to a power source. Apply an electric current. When the electric current is applied, the water molecules are broken down into hydrogen and oxygen atoms. The hydrogen molecules collect at the negative electrode, the cathode, while the oxygen molecules collect at the positive electrode, the anode. Collect the hydrogen. Once the hydrogen has collected at the cathode, it can be collected and stored in a separate container for later use. It is important to note that the oxygen produced in this process is also a valuable byproduct that can be used for various industrial applications. Optimize the process. There are several ways to optimize the electrolysis process to increase efficiency and reduce costs, such as using renewable energy sources, such as solar or wind power, to generate the electricity needed for the process. Overall, creating a hydrogen plant from water involves setting up an electrolysis cell, applying an electric current to the water, and collecting the resulting hydrogen gas. With the increasing interest in hydrogen as a clean and renewable energy source, this process has become an important area of research and development. Here are some additional details about the process of creating a hydrogen plant from water. Choose the right type of electrolysis. There are several types of electrolysis cells that can be used to separate hydrogen and oxygen from water, including alkaline, proton exchange membrane, PM, and solid oxide electrolysis cells, SOECs. Each type has its own advantages and disadvantages in terms of efficiency, cost, and scalability, so it is important to choose the right type for your specific application. Purify the hydrogen. The hydrogen produced in the electrolysis process may contain impurities that need to be removed before it can be used as a fuel. Common impurities include moisture, oxygen, carbon monoxide, and carbon dioxide. There are several purification methods available, such as pressure swing adsorption, PSA, and membrane separation. Store the hydrogen. Hydrogen is typically stored in compressed gas cylinders, but other storage methods such as metal hydrides and cryogenic storage are also available. The choice of storage method depends on factors such as the volume of hydrogen needed, the required pressure and temperature, and the cost of the storage system. Use the hydrogen. Once the hydrogen has been produced and purified, it can be used as a fuel in a variety of applications, such as transportation, power generation, and industrial processes. Hydrogen fuel cells, which convert hydrogen into electricity without combustion, are becoming increasingly popular as a clean and efficient alternative to traditional combustion engines. Consider the environmental impact. While hydrogen is a clean and renewable energy source, the process of producing it from water can have environmental impacts if the electricity used in the electrolysis process is generated from fossil fuels. To minimize these impacts, it is important to use renewable energy sources such as solar or wind power, and to optimize the electrolysis process to minimize energy consumption and waste.